Affect the properties of a two-dimensional figure. Think about this question during the lesson. A landscape architect shows a plan for a new patio to a client. The client wants the fire pit moved 6 feet to the right and 3 feet farther from the house. Where should the architect place the fire pit? How will the client's request change the fire pit? To think about where to place the fire pit, first, how can you represent the problem situation? A transformation is a change in the position, shape, or size of a figure. A translation is a transformation that moves every point of a figure the same distance and the same direction. Which property of the fire pit will the architect change?
Select your answer.
The architect translates or slides the fire pit 6 feet to the right and 3 feet away from the house. This is the new location of the fire pit. The fire pit has been translated. Each part of the pit has been moved an equal number of feet to the right and an equal number of feet away from the house. The fire pit still has the same shape, size, and orientation. Now you know how a translation affects the properties of a two-dimensional figure.
The clients also want the small table below the window moved 5 feet to the right. Where should the architect place the small table? Draw the new location of the table on the plan.
I'm assuming that this right here is the small table that they want to be moved 5 feet to the right. So 5 feet to the right will be this way. So this is not going to be exact, but I'm going to say that should be, it says 5 feet to the right, so I'm just going to assume that might be here. I don't know exactly how long the distance would be, but let's just say about here. The main thing is understanding that it moves 5 spaces to the right.
Polygon ABCD has vertices A, -1, 6, B, 4, 5, C, 2, 2, and D, -2, 0. Graph and label the vertices of ABCD and A', B', C', D', its image after a translation of 8 units down and 3 units left.
All right, so we graph that, as you see here. And then you translate each vertex 8 units down and 3 units left. So here's the original polygon, and then you move it 8 spaces. So this is the bottom point. You move first. So you move it down to 8 spaces. And so as you see all of the arrows going down, and then it's said to the left. So then you see the arrow bends to the left and it counts over 3 spaces for each point. So you redraw those new points and connect them, and you get your polygon drawn in the translated space that they asked us to do. So here it is here with these new angles, and it says congruent figures have the same size and shape. If the second figure can be obtained from the first figure by translation, then the figures are congruent so that they're the same.
What is a rule that describes the translation that maps trapezoid PQRS onto trapezoid P', Q', R', S'?
All right, translation maps every point. So they moved it here to the right, and then they went up. Let me just go back so see that again. All right.
Triangle ABC is translated 5 units right and 1 unit down. Graph and label the image A prime, B prime, C prime. If the measure of angle A equals 30 degrees, what is the degree measure of angle A prime?
All right, so 5 units right, 1 unit down. So 1, 2, 3, 4, 5. Let's see if I could just use, okay, 1, 2, 3, 4, 5. Okay. And then this one is 1, 2, 3, 4, 5. Oh, and then it's 1 is down. Let me move this down. Oh, I gotta start over. Okay, let's start with that again. So 1, 2, 3, 4, 5 to the right and 1 down. Then this one the same. 1, 2, 3, 4, 5, and then down. And then this point 1, 2, 3, 4, 5, and then down 1. So there it is. All right, so we're done with that. And so it says if angle A, which is up here, is 30 degrees, what is angle A? So in the new triangle, it would be the same measurement because these are congruent. So angle A here will both be 30 degrees.